Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through capacitors. What are capacitors and the related equations for finding different parameters of capacitors. Now, capacitors are devices that store energy. So they store energy in an electrical network. That is the major role of capacitors. And they store this energy in their electrostatic field. So let's see, every capacitor has two parallel plates. One plate is positively charged, the other plate is negatively charged. And there is an insulation at this portion. This insulation here is separated at a distance d. So the charge here is the same as the charge here, but of opposite polarity. Now, since you have seen this, that every capacitor has two parallel plates, and this plate here has been separated by a distance d to create insulation. The insulation here, we call it dielectric. So let's see, we have different types of dielectric. Dielectric can be air, it can also be rubber, you can also put wood. So when you have a capacitor in its container, as you see it, it has these two plates with the dielectric between them. Let's see something. If you have a circuit and there is a capacitor connected to a source, when you close the circuit like this, positive will move to this side, and that is this positive. The positive will be stored. So this circuit here, the current doesn't cross because the positive will be stored here and negative will be stored here, and this is what we call charging a capacitor. Charging. So when you are charging your phone, you are charging, it means that you are storing charges at the terminals or at the plates of a capacitor, and this place is our insulation. So how do we get the capacitance? Capacitance is generally equal to quantity of electric charge which has been stored over the voltage difference between the point here. So to know the capacitance, that is the quantity of electricity this capacitor has been able to store, is equal to the quantity of electric charges all over the total voltage produced or given to it, or the potential difference between its plates. That gives us the capacitance of a capacitor. And this is the first equation in our lesson. The next equation, I'm going to show you a detailed equation. C is equal to epsilon naught multiplying epsilon r multiplying area all over d. And this equation is used to derive the capacitance also of a capacitor. Epsilon naught is permittivity of free space. That is permittivity, how free space can be how you can permeate space, and that is a constant. So we have the permittivity of free space here, and this is relative permittivity. Then this is the area of the plate, that is the electrode area, and d is the distance between the plates, and this also gives us our capacitance. So the focus of this lesson is to know these basic formulas. Then also the energy stored in a capacitor is equal to half kV. This is the quantity of electric charge, this is the voltage, and this is equal to, so since our V here, or our Q here, is C times V, we can replace it and we get half CV squared as the total energy stored in a capacitor. As part of the applied electricity course, you are supposed to know how capacitors are used in the VI relationship, that is the voltage to current relationship in a capacitor. Now, To find the current in a capacitor is always equal to C capacitance times the V over the T. And this is because we apply an alternative current AC, so the voltage will constantly be changing. To find the current, we have the capacitance times the change of voltage over time. And this is the important formula you should have in mind in the course of our lesson so that you apply. Thank you for being with me. Please subscribe if this is the first time you are visiting this channel. Turn on the notification button so that you get updated for new videos. Then please share to your friends.